Welcome to homework.
Hello everyone, today we're doing chapter 23, problem 40, and this problem asks us to draw the enol form of this molecule and explain why it's aromatic, and then also explain why this molecule is drawn in the keto form, even though the fact that the enol form is aromatic. So typically when we talk about enol keto tautomers, we're talking about carbonyl groups with alpha carbons and alpha protons, but here we have this carbonyl group here, and then we have a carbon on the right, but that has no protons to be considered alpha protons. But then we have a nitrogen on the left, and that actually has a proton. So in this case, it's kind of a unique case in which your nitrogen is actually going to be your alpha position, in which it has this alpha proton off this nitrogen atom. So the enol form, using nitrogen's lone pair electrons, you're going to form a new pi bond here, meaning making a bond, you make a bond, you break a bond, and then you're going to form your enol tautomer. But what's unique about this is that you don't actually require anything to deprotonate your nitrogen first. Because the nitrogen has that lone pair of electrons, it can just use that to form the enol tautomer of this, forming positive charge and negative on itself and negative charge on oxygen. And then we have now our aromatic ring. And the reason that it's aromatic is because we see that we have 2, 4, 6 electrons all in pi rings and all in conjugation to each other. So because we have a cyclical structure, 6 electrons all in conjugation, we know it follows Huckel's rules, the 2n plus 2 rule of pi electrons. So we know that in this case n equals 2, so, or sorry, 2n plus 4 rules, so we have 2n plus 4. So here n equals 1, so we have 6 electrons, so we know it follows Huckel's rule for aromaticity, and we have 6 electrons all in conjugation to each other, so this is why it's an aromatic ring. And now, the reason why it's not drawn is in this enol form and instead of this keto form is because here we have a positive and negative charge. The total charge still equals neutral, like in the starting material, but we're separating the charges now between 2 atoms or 3 atoms here. You have negative charge on oxygen, then carbon, nitrogen, positive charge on nitrogen here. So because of that, nature tends to like everything to be neutral. If it can avoid having charges, even if those charges sum up to neutral, it'd rather just have some sort of arrangement that there'd be no charges whatsoever. So because of that, this keto form is much more favorable, even though it's non-aromatic than this enol form, which is aromatic, therefore more stable, but separation of charges occurs on this structure here.